Hi, I'm Pradeep, co-founder of Aerostrovilos Energy. We are a Chennai-based company that is working on developing micro gas turbines. So you have a cut section over here of our system, and what we kind of do is basically develop this micro gas turbine, and we have a patented combustion technology around this whole development. So we at IIT Madras, in partnership with Aerostrovilos and IIT Madras, have developed a LDI combustion system where we are able to burn multiple fuels. So in some sense, our combustor are fuel agnostic and have very, very low emissions. And we have low emissions to an extent of almost 10 to 100x reduction in NOx and other emittents. And how we are basically doing is by changing the entire architecture of combustion that has been traditionally used. Coming back to the product, so in terms of the micro gas turbine that we are developing is a 100 kilowatt unit, and more suitable for power generation and industrial combined power and cooling. We can look at basically the exhaust air with an absorption chiller that can enable a huge amount of cooling that the industry requires, like for example, for a milk industry or basically a food industry, which needs both power generation for its other processes and also cooling for storage. This would be an ideal candidate for them, where they will be able to get efficiency all the way up to 80%. So fuel to energy extracted will be about 80% with the micro gas turbine. The system is extremely robustly designed. It's a very simple architecture and can run up to about 8,000 hours of continuous operation, 6,000 to 8,000 hours of continuous operation, depending upon conditions, where you don't need to shut down our system at all. So it's ideal for 24/7 operation, where power generation is very critical, and also keeping your plant for 3 shifts continuously. We will be the ideal system that can generate power and cooling.
So can you explain the principles of operation, air intake and all that?
Yeah, so let me just explain the overall architecture and how the system works. So this is based on Brayton cycle and a little more specific recuperated Brayton cycle. So what we have is basically, if you see, is that we have a recuperator that is on the outer side of here, and then there is a compressor. So what happens is the generator first acts as a motor, starts spinning the compressor, where the air is inlet. The air inlet goes in and compresses at about 4 bar pressure. So about 4 to 4.2, it compresses the air with a single stage and then moves the air towards the recuperator. So the compressed air gets preheated from the exhaust. So the recuperator's job is to kind of preheat the incoming air after compression. And once the air is preheated, it directly goes into the combustion chamber. This is the patented combustion chamber that we are talking about, which is basically lean direct injection, where the air and the fuel is exactly mixed inside the combustor rather than pre-mixing them. So the premixed, the direct injection combustion is ignited over here, and then further the temperature goes up and then exhausted through the turbine, which is located over here, before going out and then preheating the incoming air, and then the charge is going out. So this system is a single stage Brayton cycle, where we are able to achieve about 45% of electrical efficiency through this generator. So after the start, the generator will, this motor will become generator. It's a dual purpose, it's a permanent magnet, high speed machine. And this system is also extremely compact. So if you look at the whole thing, for about 100 kilowatt is less than 1 meter, compared to your diesel generator that is about 3 to 4 meters in length and height. This is just about 1 meter size. So it's extremely compact, small, and completely vibration free, because it's only having a single rotating components and there is no moving parts other than this central shaft.
Okay. What sort of materials you guys are using to make this?
And talking a little about the materials that we are using. So what we have done to ensure that there is good amount of affordability and then good amount of experience of ownership in terms of the total cost of ownership, we have made sure very consciously that we use as much as automobile grade materials as possible. So when you look at the compressor is more of aluminum, 6 series aluminum, which is generally used in the automobile segment, and also the turbine is Inconel 718, which is very similar to that of a turbocharger based material, and the same as the turbocharger construction as such. The recuperators are made of SS, grades of SS from 316 to 347 is what we are using to ensure that there is a good amount of life in the temperature, the range of temperature that we are offering. And one of the speciality over here is basically this whole system runs on airfoil bearing. So this ensures continuous operation, no lubrication, oil lubrication is required, and it can deliver a really high life without much problem or without any stoppage that is required. And there is also no cooling fluids that is required to cool this engine. It is completely operated, it completely runs hot, and then it can stay there for n number of hours over there. Also, the whole material of construction is ensuring that we can use hydrogen in our system, so that there is no material damage whatsoever. And it is completely compliant with coatings and other things, and to ensuring that the material does not degrade with hydrogen.
Okay, so where you guys are in terms of development?
So currently we have a prototype running in our lab back in IIT Madras, and we are looking at pre-orders right now. We will be close to commercialization in about 18 months.
Thank you.